Welcome back, guys. Today we are back with another problem. Today's particular problem statement is converting a 2D, showing a 2D linked list representation of a 2D matrix. So what, in short, basically I will tell you that you will be given a 2D matrix, and you have to convert this looking like this into a form of a linked list. So 1, 2, 3, like this. So there will be rows and columns, and the rows and columns are being given as input. So whenever you see this is the input value, the 2D matrix looks like this. This is the first row, this is the second row, and this is the third row. So when you write it, when you put the input should be in this format: 1, 2, 3, 4, 5, and 6, 7, 8, and 9. So this is how the initial input would look like. But now my task is to convert this. Now my task is to convert this entire normal matrix into a 2D linked list. That means linked list cannot be 2D, but the representation should be such that it makes a 2D linked list. Nothing. So normally we know that there is one next pointer. So in this case, we will have a right and down both pointers. So we will be using the concept of two pointers. Okay. Though in this case, the pointers which we will be using will be a right pointer and a down pointer. So there will be two pointers, a right and a down pointer. So let us go and check out the algorithm. So the algorithm tells like this, that we have to define two pointers, right and down. I have already told. Right is to link a node to its right and element in the same column. So say for example, this is one column. Okay, my right element, if I am at over here at this particular position, my right element will be 3. So right pointer will be used to link to another element present at the right side. Okay, now what is there? Down, linking a node to its down neighbor element in the same column. So say for example, I'm over here at 2 and my down pointer will point towards 5. Say for example, I'm here at 1, my down will towards 4 and my right will towards 2. Okay, so that is how I can check my left, down and right pointers. Now we have to initialize the node as mat of 0, 0. So what you can see is mat of 0, 0 is nothing but the starting element. So we will be taking the starting node from 1. So we can say that whenever input node, do not consider the left one, our starting will be this one. Okay, our starting will be this particular one over here in the original matrix. Now what we have is that we have to use the row heads array. We will keep a row heads array. So what we can do is we can create a row heads array, so which will store the directions. Okay, and which will help us to track the first node in each column. So say for example, this is column 1, column 2, column 3. This is column 1, column 2, column 3. The first node in each column will be tracked with the help of the row nodes. So we can say from where, so from 2 to 5 to 6, this track of elements has to be maintained with the help of the row heads array. Okay, now what we can see, we have to build the first row, start from the head to the first row of the matrix. Then what we will do is for each element we have to create new node and return the link of the previous one. And for linking the subsequent rows, we will be using down pointer, as I already told. For moving down the matrix from 1 to 4, 4 to 7, we will be using the down pointer. Okay, so if you guys want to note down the algorithm, you can pause this video and just take the note of the algorithm. We can do this particular problem in O of n square, time complexity, and space as O of n square. Now you will ask me that, okay, fine, you have told me the algorithm, you have shown me the problem statement, but how do I solve this problem actually? How do I verify this particular algorithm works or not? So for that, I'll be using a dry run. Okay, so this is the dry run which I have made over here. You can see the step-by-step dry run is over here, the step-by-step dry run. So before I show the step-by-step dry run, make sure you guys like, share, and subscribe to the channel. And what we have over here is a n cross m matrix, So these has 1, 2, and 3 rows and 1, 2, and 3 columns. So these are the rows and these are the columns. Okay, so we have rows and columns. So initially what we will do in order to make this into a connected linked list. So how a linked list look like is, linked list should have the reference. These have the reference. Linked list should have the reference between among each elements. Okay, so what we have to make this, and how we can return exactly same matrix into a linked list which looks exactly same. So what we will be doing is, first we are taking our head value as 1. Now our row head is pointing from 0 to 1. Okay, fine, because initially we initialized it with 1, so it will point towards 1. Now let us move to the second. So now my head is 2 and my row head is 1 to 2. That means I'm moving in this direction. That means I'm moving from 1 dot right equals to 2. So whenever I'm writing 2, remember this is nothing but 1 dot right equals to 2. That means 1 dot next equals to 2. Right? We used to write previously data dot next. Similarly, we'll be using in this case 1 dot right equals to 2. So we can say that this is my right side. So I have achieved one right side, but I have to complete one entire row. Then only I can give a link, right? So I will move to the third value and I will make a link with 2 to 3. So my now row head is pointing towards 3 and my right will become 2 dot right, 2 dot right equals to this 3. So that's how I'm getting this 3. Now when I return this head of the linked list, when I return the head at point this one, at per this situation, I will get a 1 2 3. So I can see easily that 1 2 3 is being now framed. The construction of the bone of the skeleton of the linked list, the first row is being constructed. Now let us move down. So while moving down, we will have another pointer. So now we can see that for moving down, we have a pointer as 4. Now my head is pointing towards 4 and 0 is pointing towards 4. That is also understandable. Now what we have, we will move towards the 5th direction. Okay. So from head equals to 4, we will move my head value towards the 5 value. My row count will move from 1 to 5. Okay. That is also understandable. And what next we have? 1 to 5, and my right will also move towards 5. Fine, from 4 to 5 I am moving, that's why I am putting the right value as 5. That's from 4 to 5 I am moving, that's why I'm putting right as 5. Okay, and after I've put the value as 5, I also have to put the down value as 5. So now you will tell me why down value, from where down value is coming. Initially down was 2, so we are coming down towards from 2 to 5, that's why we'll put a 5 as the down pointer. Okay, now what is there next? What is there? So initially what we can see that we have covered up this part. Now we will move towards the head as 6. That means I am currently at this position. Now from here, can I go anywhere here? No. That's why you can see from 2 to 6 it will point. Okay, that means it is saying from 2 to 6 you can go, means from row heads 2 to 6 you can go. Okay, and from after that, what else is left? What else is left? I move towards the right valve. Okay, so what I can clearly show the relationship over here, I can show the relationship. Sorry, this will be 5 because I'm moving from 5 to 6. So the relationship, I can say that my 4 5 and 6 is also completed. So I can write 4 5 and 6 is also completed. Okay, this relation has been completed. So what is there after 6? 9 is not there, 7 is there. Okay, so we'll put the down counter as 7. But how does 7 is interacted? 4 will point towards 7. That's the reason I write 4 dot down equals to 7. Now the head value is storing 7. Again 7 is starting from 0 over here. So the row heads will point towards 0 to 7, and there is no right direction at present. It is not moving anywhere. So 7 will be as it is. After that, you guys can solve by yourself as well. So you can see that now we have to go to 8. So I'll put my head as 8 immediately. Now my 1 to 8. Okay. Now my row will move from 1 to 8. Okay. And my right direction is nothing but 7.8. That's the reason I have written over here 7.8. So my right direction is completed. And 8 is where? 5 down. Means 8 is located somewhere below 5. That's the reason I'm putting 5 dot down is equals to 8. Okay. The exact same manner, I am left with 9, right? So my updated head will be 9, and 9 is located under which value? 6. So I will write 6 dot down equals to 9, and my 9 is being pointed from now row head is updated, so I can write row head as 2 to 9. Initially it was 0 1 2. Every time the row heads array will create a new row heads array, which will store the heads of the rows. And 8 dot right equals to 9. This is very simple. 8 dot right equals to 9 because I'm moving from 8 position to 9 position over here. Okay, and finally my list will be constructed. So what I can see, my 2D linked list is finally complete. This process can go infinitely long depending on the value you are taking. We can use a long data type if we think that our value might go larger. Okay, so after this, what we can do is we can just go and check out the final structure, which will look like exactly 1 2 3 4 5 6 7 8 9, exactly same as the 2D matrix we started with. So now we will go back and just check our code whether it works or not. So what I've done in the code is, let us first try to understand. Okay, let us first try to understand. So what I'm doing is, first I'm constructing the node of the linked list. Before that, I've made a node class. I'm passing a 2D matrix over here in the node constructor. I'm checking the length of the matrix. If it is null, we'll return null. And the head is pointing towards 0 0. I have already told that it will just point towards the initialization has to be done with 0 0. Now new row heads are being stored, and now we are iterating through the first row of the linked list. That's the reason we have put j1 to n and j++. And from there, now we are moving towards the right direction. So what I'll be writing, temp.right equals to new node, and temporary equals to temp.right, and in the j we are going to store the temp.right position. The pointer, remember what the links we have made from 0 to 1, from 1 to 2, 2 to 3, all these heads have to be stored. Similarly, the remaining subsequent rows has to be stored like this. So for the condition of subsequent rows, there will be I and j, just signifying the row and column. And what we can see, we're starting with the first node. The nodes are being created and stored over here. Down is being used to point towards the down array. Similarly, down pointers are also being put over here. Lastly, we will return the head of the linked list, which will give me the exact value. So what you can see, I've put the 1, 2, 3, 4, 5, 6, 7, 8, 9 as the input values. So you will ask me from where I'm taking the input. I've made a main method. Okay, and main method is pretty cumbersome and long. So if you guys have exams where they tell you to make main methods, you guys can take a screenshot of this code and try to understand how we are taking the input of the entire 2D matrix. Now I'll just run this, execute this program. So if you see, exact same values will start to appear: 1, 2, 3, 4, 5, 6, 7, 8, 9. That means the linked list is successfully created. That was all about today's particular problem statement. Make sure you guys like, share, and subscribe to the channel. And we will be solving another problem very soon. Thank you so much.